Welcome to the last tutorial on Computer Numerical Control, where we will go over a complex design. In this tutorial, we will continue on from the things learned in the intermediate code tutorial. As you will remember, Computer Numerical Control, or CNC, is a coding language used mostly in manufacturing, in which the programmed commands, stored on a computer, precisely control the machine automatically. Most CNC coding is used mainly for milling, but also includes turning and plasma cutting to make higher quality parts, faster and cheaper. For this tutorial, you will need the PDF attached here, a piece of engineering paper, and a pencil. Before watching this series of CNC tutorials, it would be to your benefit to review the flashcards on Study Blue to learn what each line of code means. This tutorial will require you to watch the previous two tutorials in the CNC series. For this complex code, we want you to practice the code on your own. You should feel comfortable now with CNC coding, and if you want to challenge yourself, continue watching this complex design. We will not be doing a talkthrough, but rather working through the code on the screen. If you have questions, refer back to the prior two videos in the Computer Numerical Control series. Let's begin. For our first line of code, we want to designate everything to be in inches, so we will use a G20 code. This line designates the tool being used because of the T code. The number 0.375 is the tool that we will be using. For this instance, the tool has a diameter of 0.375 inches. And M is a miscellaneous code. But for this design, we are telling the machine to make a tool change to the 0.375 tool. When the computer sees a M06 code, it will go find the last stated T code to make a tool change. For this line of code, we notice an M03 code, and this tells the machine to start the spindle in a clockwise rotation. Then, looking at the S1000, this is the spindle speed we want to use, 1000 RPMs. This line of code, the G04, tells the machine to pause. We want the machine to have some time to get the spindle speed up to 1000 RPM before it starts cutting. If the spindle speed is not at the correct rotation rate when we start drilling, it will either not cut properly or dull the tool bit down. The P40000 tells the machine that dwell time, or pause time, is going to be 4 seconds. This 4 seconds was an estimate for this tutorial since we don't know the variables of the machine. While cutting the part, we want to make sure to turn the coolant on, so we will use a M08 code. This will tell the machine to flood the coolant as fast as possible to reduce friction and prevent heat hardening. Since we are doing a pickup to be followed by a tool change, we want to make sure to turn the coolant off with a M09. This will tell the spindle speed to stop so we can change the tool. This M06 will change the tool to the last previously established tool. In the example, it will be the T.25 from line N0030. For this line of code, you will notice a M04 code. This will turn the spindle on counterclockwise to start cutting. The spindle speed will be set to 2000 RPMs. For this line, we will use a N07 code, which means we will mist the coolant onto the part instead of flooding. Now that we are done machining our part, we will want to tell the machine this is the end of the program with the M02 code. This wraps up the Computer Numerical Control tutorial series for supplementation to IE 248. Feel free to come back and watch these videos if you need a refresher in preceding courses and your future career. Thanks for watching, and we hope this tutorial helped to challenge you with a longer design of CNC coding.